I'm T. Ruchitra from BECSC IoT department. So today I'm going to give a seminar on A-star search. So A-star search is one of the most popular and powerful algorithm used for pathfinding and graph traversal. So it combines the advantages of both uniform cost search and greedy best first search. And the main advantage of A-star search is that it uses heuristic function which estimates or calculates how close the current node is to the goal node, and it is widely used in many applications like game development, robotics, and GPS. So this is the formula of A star search, in which f of n refers to the total cost of each node and g of n refers to the cost from the current node to the start node, and h of n is the heuristic value which estimates or calculates the cost from current node to the goal node. So the formula of greedy best first search is similar to this formula, but the only difference is that greedy best first search doesn't use h of n, which is the heuristic value. So A star search is more advantageous than greedy best first search. As I said before, A star search is used in many complex applications, but to explain it clearly, I have taken this diagram. So the circles, which are also known as nodes, represent different locations like S, A, B, C, and so on, and the lines connecting the nodes represent paths between these locations. And the numbers between two nodes are known as g of n, and the numbers on each node are the heuristic values. And in this diagram, S represents the source node and G represents the goal node. There are many feasible paths to reach the goal node, but we have to choose the path with the minimum cost. So the A-star search contains two lists, namely the open list and the closed list, and we should start with the open list containing only the initial node, which is S in our case, and we should set the g of n value of S to 0 and h of n value to its heuristic value, which is 11.5. Now we have to calculate the f of n value of S node, which is 0 plus 11.5, and then we have to set the closed list into an empty list. Since we have only one node, we don't have to check whether the f of n value is minimum or not. So in the next step, we have to generate the successors of ns node, which are a and d, and we have to calculate the g of n, f of n, and h of n of a and d. So the value between s node and a node is 3, and the value between s node and d node is 4. So the g of n value of a and d are 3 and 4 respectively. And now the g of n value of a is 10.1 and h of n value of d is 9.2. So now we have to calculate the f of n value of both a and d. As I mentioned before, the formula of f of n is g of n plus h of n. So after calculating the f of n value of both a and d node, we have to check which node's f of n value is the minimum. So in our case, the f of n value of a is lesser than the f of n value of d. So in the next step, we have to generate the successors of a node. In the previous step, we have to place the S node on the closed list, since A and D are the successors of S node, and the successors of A node are D and B. And same like the previous step, we have to calculate the values of G of n, H of n, and F of n. And since the f of n value of b is less, we have to generate the successors of b node, and the successors of b node are c and e. And in this case, the f of n value of d is less, so we have to generate the successors of d, and we have to pass the b node on the closed list. And the successors of E node are B and F, and in this case the f of n value of F is less, so we have to generate the successors of F node. And after generating the successors of F node, we can see that the successor of F node is G, which means we have reached the goal state. And the optimal path is S to D, D to E, E to F, and F to G. A-star search algorithm is widely used in many applications since it efficiently finds the path to our goal. The best example is GPS, because we use GPS in our day-to-day life to find the shortest as well as the best path to our location. And the next example is robotics. So A-star search is used in robotics so that it can be helpful for the robots to navigate through environments and avoid obstacles. And it is also used in game development, like in video games and 8 puzzles or 12 puzzles.